What's up, Inspire Vision, plus anybody I might be catching on YouTube? We are now on day 7 of our 18-lesson summer school accelerated Algebra I course. So, today we are doing lines of best fit using linear regression on scatter plots, and we're doing our correlation coefficient. And the purpose of this is to get us ready for STAAR, so it is time to learn some math. Now, here's how today's going to work. We are in reporting category 2, TEKS 8.4. We're going to do one STAAR release question to introduce us to our topic, then 5 guided practice questions, and only 5 independent practice questions today. Then we're going to do one more STAAR question to practice what we've learned. So hit the subscribe button and the like button so you can get each of the 18 days to help us prepare for STAAR. All right, now heads up for tomorrow. We will be doing a notebook check while you're taking your quiz tomorrow. So bring your notebook days 1 through 8 and have those ready. We are also going to learn one more concept before we quiz, but I'll get us ready for that. And we're going to do a review over days 5, 6, and 7. So if you're watching YouTube, make sure you've checked in on days 5, 6, and 7 because all of that is happening on day 8. Okay, here's our question for today. The question for today is, they give us a graph and they're trying to ask us if this trend continues, what will the population be in 2015? So we're asked to make a prediction for 2015. Now, what you could have done if you didn't know today's lesson is you could have drawn a line out to where you think 2015 would be and then see where that hits the graph. But that's not a very accurate way to do this question, and you could make a mistake doing that. So here's a much better way to do this question. Since they gave us 2 points on the graph, we could write an equation just based off of that. And to get an equation, we know we should use our stat key because that's what the stat key is for, is to help us get an equation. Then, after we type these points into stat, do stat calc 4. Also notice that we're typing in 0 for 2000 and 10 for 2010. So if we're trying to find 2015, we would think that number would be 15, not the actual number 2015. But stat calc 4 has an equation. Now, very important for today. Every time we get an equation, we're going to want to make note of this on our paper because after we write down our equation, and in this case it's 5.7x plus 193, we're going to want to type it into our y equals key. So we're not going to want to do that by memory because we're going to need to go through these steps. First stat calc 4, then y equals like this, and then the fourth step, go to our table. And like I said before, since the way they made our table, 0 means 2010, 10 means 2010. Sorry, I said that backwards. 0 means 2000, 10 means 2010. 15 would be 2015. So here's our answer right here, 278.5. But on the y-axis, they're talking about in thousands. So if we put 2 zeros behind that, we have our answer as B. Okay, this is pretty much what we're doing today. So our first guided practice question. So they have a whole bunch of sentences that's talking about youth development in soccer, years registered as population. But then here comes the real core of the question. It says use linear regression to generate a function for best fit of the data. Well, that means using our stat key. So if we put these numbers into stat, then get an equation, we can use the equation to predict for year 21. So first stat, your top numbers are going to be your x's, which are your L1s. Your bottom numbers are your y's. So this is the first thing you do. Then you do stat calc 4 to have 57.42 as your slope. Your y-intercept is 2,460.68. You need to make sure to write this down because next, since we're doing a prediction, we're putting this into our y equals key. Then we just go to our table and then scroll down to 21 because that's the number we're trying to predict. Now, if you notice, they did 3,666.5, but since they're talking about players, they're going to round up so your answer is going to be C. All right, first question out of the way. Here comes our second question. Now, this one's a little bit different. The whole purpose of this question is linear correlation coefficient. Now, linear correlation coefficient, we're going to use the lowercase r to represent that. And you have to do these following steps in your calculator. Every time you turn your calculator on or your memory is reset, you're going to hit second 0, scroll down to D's, find diagnostic on, which is a little ways down, and then hit enter twice. So if you have a calculator at home, you need to go ahead and do this to where you see diagnostic on done. Otherwise, there is no way we can figure out what our correlation coefficient is. But once you have done this and you have this in your memory that you always need to have this on, then you're just going to type in the stat like this, stat calc 4 like this. Now here's what's weird about correlation coefficient. Because we turned diagnostic on, we now have r squared and r on the screen. So we have two extra numbers on our screen. Now correlation coefficient is just the r by itself, not r squared. R squared is for quadratics, but since they want linear correlation, we're just looking at r. So ignoring r2 or r squared, we're just looking at r, and we're going to round the first two decimal places. So it's going to be 0.78. Now, also something very interesting about correlation coefficient. This question doesn't ask us, but we might get a question in the future that will ask us. See how 0.78 is pretty close to 1? That means that these points, they would not make a straight line if you were to plot them. They would be scattered. That's where the term scatter plot comes in. But they were pretty close to a straight line because they're pretty close to 1. Now, if they were close to -1, that means they would be going down. Since they're close to +1, that means they're going up. So they have a strong positive relationship. If our R was close to 0 or 0, that means the points have no relationship, which means the equation cannot be linear. It would have to be quadratic or something else. All right, moving on. Number 3. So this time, the last sentence says, using a function, how much energy is predicted to be needed in year 9? So again, we're predicting values, so we have to go through our 4 steps. First step, put this into stats, like this. Second step, stat calc 4 and write down our equation. Now, we still had our diagnostic on, so we see these extra numbers, but we're going to ignore r squared and r. We're just going to focus on a and b because that's what we need for our equation, because we're trying to fit our equation into ax plus b. So our equation is 17.5x plus 212.5. We need to make sure we write that down because in order to make a prediction, we're going to use our y equals key and then go to our table. And since we're predicting year 9, we're going to go all the way down to 9 and we see 370. Now our answers are in scientific notation, so they just put a decimal place after the 3. Okay, moving on. Number 4. Again, linear correlation coefficient. Don't get scared about these terms. All that means is we're going to type them into stat. Make sure your diagnostic is on, but we're not going to have to turn it on after each time we do a question like this. That's the beauty of if you turn it on at the beginning of your test or your quiz, then you don't have to return it on later, only if your calculator memory was reset. So, and again, to reset your calculator memory, that was second plus 712, which is a good thing to do anytime your calculator is not doing what you want it to do. Okay, so we have diagnostic on, which means you type it into stat. Then you do stat calc 4. And for linear correlation coefficient, you're only focused in on the R and you're going to round it 2 decimal places. So that's just going to be negative 0.98, which is really close to negative 1. So if I was to plot these points, they would almost all fall into a straight line, which shows a negative downward sloping line. All right, last question for today before you all start your own 5 questions. This question's talking about an equation of this graph line. So we really got to get good at these questions, and you should notice right away that you're given 2 points. And since we're given 2 points, we need to make an equation out of this. Now we could use rise over run in our y-intercept of 6, or you can use your stat key, type in -2, 0, 0, 6, stat count 4, and then we're only going to focus on A and B. So your equation is 3x plus 6. Now here's what makes this question tricky, and you can be guaranteed to see this on STAR and your quiz tomorrow, a question just like this. All of your answer choices, none of them have 3x plus 6. So we're not going to guess, we're going to solve. And because we're solving for y, that's the whole reason I've taught you rectangle and triangle. So for our rectangle, since we're solving for y, is the positive 3 in front of y, because our rectangle is always in front of the letter we're solving for. And our triangle in this case is 1x. So our next thing we're going to do is always remember that we get rid of the triangle first by doing its opposite. And this 1x is really adding, so we're going to subtract 1x on both sides. Then we're going to remember the very special thing is -6 minus 1x is not -7. It's not -7x. They are side by side because they are not like terms. This happens anytime you're solving for y. So since they're side by side, you write them like this. Now we need to get rid of the 3 that's in front of y by doing division. So -6 divided by 3 becomes -2. And -1 divided by 3 is -0.33 repeating, which I can make that into a fraction to be -1/3 x. Now this equation is not the same as the equation we're trying to match up to, so we do the same thing on B. Where's our rectangle on B? Well, that's the number in front of y. What number's in front of y? That is a 1. So that's the rectangle and triangle is the 3x. So we're going to subtract 3x on both sides. Then that's going to be 1y, because we're going to bring this down, is these both are side by side because they're not like terms. And if we divide by +1, nothing changes. It's only if we were dividing by a negative number that these signs would change. But this is not my answer, but it's close. The only difference is both these are negative when both of these are positive. So we keep going. On C, our rectangle is -1/3, but that would mean we have to divide by -3 later on, just like we did on A. So we know since we're dividing by 3, that is not going to give us a +3 as our slope. So using the clue from B, the question that's closer to B is D. So using or solving for D and subtracting 3x on both sides, we're going to have -1y equals -6 minus 3. Now the difference between D and B is there's a -1 in front of y. So if we divide by -1, that changes both of my signs to be positive. So now I have 6 plus 3x. And these do match. They just reverse the order. Okay, so here's what's going to happen next. I'm going to show you 5 questions. But since they are kind of, they're using a lot of tables, I could only fit 1 to 2 questions per slide. So you're going to need a pause, write down the question or do the question on a piece of paper before you see the next question. So number 1, here's the question. Number 2, here's the question. And I'm moving on to the next slide now. 3, here's the question. And I'm going to want you to do these questions on your own before you see my answers. Here's number 4. And finally, number 5. Okay, so number 1. The key in number 1 is they want us to use linear regression to generate a function, which we will, and then they want us to know how many are expected to register in year 6. So that means we're going to start by putting these into stat. Then we're going to do stat calc 4. Since we're trying to get an equation, we're going to focus on A and B, and we're going to write that equation down. Then we're going to type that into y equals, and then we're going to look at our table at year 6. And we see that this is really close to 3,904, which is our answer. All right, number 2. Linear correlation coefficient means you type them into stat calc 4, and we're only focusing on the R. So if you didn't see your R, then that means you didn't turn your diagnostic on. So that is C. All right, number 3. The tricky thing about number 3 is they only are focused in on temperature and number of people. So they gave us 3 columns. We don't ever want to type 3 columns into our stat key. We only want to type in temperature, number of people. And the reason why I know these 2 are used is because temperature is on my x-axis, number of people is on my y-axis. So that's what I'm typing in the L1, L2. No L3. That would be bad. Then I do stat calc 4. Now, the thing about this is I only want to go to 2 decimal places or so after the decimal point. And if I go 2 decimal places, I'm going to see 5.92, and then plus minus 125.55. Now, plus minus is a bad thing to write in math, so whenever you see plus minus, just write it as minus. So here's our equation. And that matches up with C because they rounded to the nearest whole number. Okay? Next question. Number 4. This time we are asked to find a linear equation, a function or a best fit. Function means just an equation. And then we're going to predict month 8. So first type them into stat calc 4, only focus on A and B, then write that equation down using 2 decimal points like this, type it into y equals, and then look for month 8 on our on our table. Table again is second graph. So that means we have 1,958. 1,958 is C. Okay, last question before we do our star question. This time we're asked to generate a function, that means an equation, for year 12. So if I type these into stat calc 4, and then go 2 decimal points, I have this. Now if I type that into my y equals key and then look at my table, I see $3.92. Now $3.92 is none of my answer choices. So it's making me question because A is really close to $3.92 and C is really close to $3.92. But it's making me question which one of these is right. So what I did is I double checked all my values that I typed into stat and I saw that they were all right. Then I figured, well, it's probably because we rounded our equation why we're not getting the exact answer. So if you type in your equation not rounded, then we're going to see a better answer. So normally I suggest just round it, but in this case our answers are too close. So we're going to have to type in a little bit more numbers to get the answer. And then if we look at our table at 12, we see 3.945. Well, that made up my mind that the answer is not A, which I would have been suckered into picking if I rounded my equation. My answer is going to be C because they rounded 4 or 5 up to 5. Something tricky. Okay, now our last star question for today. So again, we're trying to predict how many numbers of this is the number of baseballs used in 14 games. And then they want to make a prediction used if 275 pitchers were thrown. Well, 275 would be about right here. I'm going to show you 2 ways to do this question. The first way we could do this is to try to figure out what the coordinates are of these points. And the points that I'm worried about the most is the very first point and the very last point. Now, I could go and find each of these points, but then that would take me forever to find each one of those points. So if I just use the first point and the last point, since none of them, they seem to fall in line, then I can get an equation just used off these points. So I typed these into stat, did stat calc 4, and then, oh sorry, there they are. So I typed them in the stat, did stat calc 4, and had this. So if I round my equation, it's going to be y equals 2.11 or 2.11x minus 485 1900. Sorry, it's a habit of me to say 0.11 instead of 1100s. But if I type that into y equals, I have this. And then if I look for 275, this is the bad thing about using calculator is you have to scroll all the way down to 275. Or if you're using a TI-84, you can do second plus, I believe, and then type in 275, and then it'll take you straight to it. But the calculator I'm using for these examples is an 83, TI-83, and I have to scroll all the way down to 275. Now, it just takes a little bit of time, but that would give you your answer. It says 95, so the one that's closest to that, and there's nothing else closer to that, would be 100. Now, let's say you didn't do it that way, or a way to double check. A way to double check yourself is to draw a line of best fit through these points. So what that means is you start with your first point and your last point, especially since they kind of all follow together, and try to draw a straight line between them. Now, it was hard for me to draw a straight line. You could probably draw a better one, but that's basically what they're asking for is you're not trying to connect all your points. You're trying to draw a straight line between all of your points. Then, if I'm making a prediction for 275, 275 is on my x-axis between 270 and 280, and then it would hit about right here on my yellow line, which is also at 100. So that's two different ways to do this question. Now, this question was actually pretty easy by just drawing a line of best fit. But I also showed you how to do it on your stat key. All right. So that is it for today's lesson. And thank you for watching. Let's be ready for our quiz tomorrow for day 8.